Welcome back to Bite-Sized AI. I'm Michael Barnes, your host, and we're going deeper today with two hot topics that are really making waves in the AI world. Randy Hill, our resident AI expert, is here to break it all down for us. Randy, let's jump right in. We've got this former Google executive out there saying today's large language models, these LLMs we all hear about, might just be the latest in a long line of systems that have fooled us before. They're arguing that the transformer architecture, as revolutionary as it's been, probably won't get us all the way to true artificial general intelligence. What's your take on this really big claim?
That's a great question, Michael, and it really taps into a significant and growing debate happening at the highest levels of AI research. These transformers are absolutely incredible at spotting patterns and absolutely massive amounts of data. That's why tools like ChatGPT, Claude, and Gemini feel so intelligent, so capable. They can write essays, generate code, chat fluently, even argue points. But at their core, critics argue, they're still essentially sophisticated expert predictors. They're generating incredibly convincing text without necessarily true understanding, real-world reasoning, or common sense from scratch.
So it's like a super advanced autocomplete engine that's just gotten really, really good at mimicking human thought rather than actually thinking. That's kind of unsettling when you put it that way.
Exactly, and we have seen this movie play out before historically. Think about Eliza from the 1960s. It was a very simple natural language processing program, but it actually fooled people into thinking it was a real therapist. People projected their own meaning onto its responses. Modern LLMs do the same thing, but at an exponential scale, with vastly more sophisticated outputs. The current dominant philosophy, this just keep scaling approach, throwing more data, more compute, more parameters at these models, is a huge bet right now. Billions are being poured into it. But many experts are saying we're going to hit a wall, that simply scaling up transformers won't bridge the gap to AGI.
A wall? What kind of wall are we talking about here? If they can do so much already, what's still missing for AGI?
Well, true AGI, as many define it, would need things like persistent memory that can learn continuously over time, not just during one interaction. It needs real-world agency, the ability to act in and understand a physical environment. It needs genuine planning capabilities, the ability to set and achieve complex goals, and to build internal consistent models of how the world actually works, including causality. LLMs don't truly grasp causality, they just understand correlations in data. They can't ask why in the fundamental sense that a human child can. They don't have embodied experience.
So, it's more than just knowing a lot of facts or being able to synthesize information. It's about genuine understanding and interaction with reality. If transformers aren't the end game, then what are these experts suggesting could be the next step? What could these new architectures look like?
That's the million-dollar question, isn't it? The consensus is emerging that we'll probably need hybrid systems. We might see a blend of deep learning like transformers with more traditional symbolic AI approaches that are better at reasoning, logic, and knowledge representation. Some researchers are looking at neuromorphic computing, hardware designed to mimic the brain's structure. Others are exploring what's called embodied AI, where the AI learns through interaction with a physical body or a highly realistic simulation, developing common sense through experience. The idea is to move beyond just prediction to actual understanding and agency. Transformers were a monumental breakthrough, but they might be a foundational step, not the ultimate destination for the AGI journey. Smart money in the research community is definitely watching for that next paradigm shift.
Fascinating. So, impressive today, but maybe not the final boss we've been looking for when it comes to AGI. It's a sobering thought, but also exciting, thinking about what comes next. All right, let's pivot to our second topic, which sounds equally mind-blowing. AI is now diving into animal languages, including sperm whales. This sounds like something out of a sci-fi movie. What's the latest happening here?
This one, Michael, is pure magic, honestly. It feels like we're on the cusp of truly unprecedented communication. Project CTI, that's the Cetacean Translation Initiative, is leading the charge here. They're deploying an incredible array of technology, AI, machine learning, sophisticated underwater robots, and acoustic sensors to decode sperm whale communication. These whales use these rhythmic click patterns, almost like Morse code, which they call codas.
Codas. So it's not like the melodic singing of humpbacks. It's more structured, almost like a secret language they've been using all along.
Very much a structured, rapid-fire communication. And recent work by Project CTI has been revolutionary. They've actually mapped out what they're calling a sperm whale phonetic alphabet with over 150 distinct codas. And here's where it gets wild. They've identified vowel-like sounds and structures that combine in ways strikingly similar to human language. We're talking about context combinations, even what appear to be regional dialects among different whale pods. The sheer scale of data is something humans could never process. AI is crunching thousands of hours of recordings from tags attached to whales, from hydrophones covering vast stretches of ocean, and from drones, spotting patterns in real time during social chats, family bonding, and even when whales are alerting each other to danger or food. It's truly a big data problem that only AI can solve.
Okay, this is phenomenal. So, are we actually close to having like full conversations with whales? Or at least understanding hello or watch out for that shark?
Not full nuanced conversations like we're having right now, not yet. But we're getting closer, much faster than anyone anticipated. We're moving from identifying individual codas to understanding sequences and their probable meanings. For example, they're starting to discern codas that might signify individual whale identities, or specific emotional states like distress or excitement. Imagine being able to understand a whale's distress call, or a warning about a nearby ship. That's within reach. And this isn't just limited to whales, by the way. Similar AI-driven work is happening with elephants, dogs, and other animal species, using bioacoustics and machine learning. We're moving into an era where we might genuinely unlock interspecies communication.
That's just incredible. I mean, the implications, Randy, are huge, not just for scientific understanding, but for conservation, and even for how we think about animal intelligence and rights. If we can confirm complex language, it fundamentally changes our relationship with these creatures.
Absolutely, Michael. The ethical questions are enormous. If we discover that these animals have highly complex conscious communication with nuanced social structures and individual identities embedded in their language, how does that impact our moral obligations? How do we justify certain human activities? It could redefine animal rights on a global scale. And from a pure scientific standpoint, it offers an unparalleled window into non-human intelligence, potentially revealing entirely new ways of thinking and perceiving the world. It's not just about talking to animals, it's about understanding different forms of consciousness and culture.
From doubting the current path to artificial general intelligence to potentially having meaningful exchanges with sperm whales, AI truly keeps blowing our minds and expanding what's possible, and also what we need to consider ethically. Randy, as always, thanks for carrying the heavy load, breaking down these complex topics, and making them accessible for all of us. You always give us so much to think about.
My pleasure, Michael. It's always a privilege to dive into these conversations with you and our listeners. The future of AI is never boring, that's for sure.
Indeed. Folks, that's our extended bite for today. Stay curious, keep learning, because the world of AI is moving faster than ever. We'll catch you next time on Bite-Sized AI. Make sure to hit that subscribe button so you don't miss an episode.